Now that we are done with our spring, let us add the damper. One could easily do a whole MOOC on friction effects and the transformation of mechanical energy into heat. If we had some time slots left, we might have a look at stick slip effects that can nicely be simulated in Simulink. For now, let us pick the easiest and most common formula for a damper, which is the damping force is minus some damping constant multiplied by the velocity. This means the faster our mass is moving, the higher is our damping force. The direction of the damping force is always opposite to the direction of movement. Now we've got a total force on the mass. This force is the sum of the gravity force, the damping force, and the spring force, which equals to the mass m multiplied by the gravity constant g minus the spring constant c multiplied by the position s minus the damping constant d multiplied by the body's velocity v. The implementation of the damper in Simulink is quite straightforward. Patrick, if you can just assist me.
Yep.
You add another minus input port to the sum block, add a gain for the damper constant, and connect the blocks with signal lines. And of course, don't forget to define the variable for the damping constant in the Model Explorer.
I'm on my way.
Okay, that's good in the model workspace. The damping constant.
And as I know you, you would like a value of 1, right?
Yes, I want to ease mental arithmetics.
Okay.
Okay, and here we've got the model with all our components.
Shall we run it?
Now we can run it and have a look. And this is how the simulation looks like with the current values. A very, very strongly damped system.
Nice curve.
Yeah.
Now let us add some modeling specific and some Simulink specific comments.
Yeah, okay.
So we start with the modeling aspect. First, the block in our model don't have to have a one-to-one counterpart in reality.
Yeah.
Often in reality, the spring and the damping behavior is provided by the very same physical part.
That's quite common.
And for the other point, the Simulink specific, I will change to Simulink once again. What I don't like personally in this model is this signal line here.
Yes,
it changes direction 2 times
yes,
without any good reason.
The routing is pretty nasty.
And there in this sum block, you already saw it some time before, there's this vertical bar.
Ah, okay.
And this vertical bar acts like an invisible input port.
Okay.
But that influences the distribution of the input ports around the circumference of the sum block.
Yeah.
So if I add a second bar here and apply this, now I have the right angle here.
Ah, okay.
If I move it up a little bit, and now these lines are straight.
It looks much nicer.
It's a kind of a brain teaser sometimes to really think about where to place these bars, that the sum block looks exactly the way you would like it to be. So I prepared right here a little something, some blocks that may come in handy and how they are to be made. Right here there's a rectangular sum block. this you use very often if you really sum. If you
Yeah,
have
yeah,
three
yeah,
pluses or something,
Yeah,
you
yeah.
use these ones. That's the one that we have right now. Right here we have an additional negative input port, and this would look like 3 bars at the start, and then the
And-
plus, minus, minus, minus.
Okay, yeah.
And right here the same thing again with 1 minus more. Right here
And one
1
bar
bar
more.
more added. You can also have it coming from above or something like this. So I just wanted to show you this.
Okay.
This just makes it look nicer. It doesn't change anything as
Okay.
far as the numeric results are concerned.
Nice.